Hi, welcome to this session. Today we are going to talk about tools. So, what are tools? When we are creating a RAG application or any GenAI application, if we want to have a section in our application, a part of our workflow, where we want to perform some kind of an operation, or we want to access a database, or we want to do just anything that can be done using functions and all in Python, we can do it using tools. So tools in Langchain is a kind of an object that can be used to call APIs, other functions, databases, for web search or any kind of application like that. So it's kind of a broad and unique framework that we can use and integrate in our GenAI applications to exceed the possibilities that we can achieve. One example that I can tell you of how tools is actually very useful. Say that we want to have a GenAI application where at some point in time we want to search the web for an answer. Instead of relying on the LLM or on the private data set that we are working with, we want to get the answers from the web as a web search response. What we can do is we can just use a built-in tool called as a Tavily web search tool. I can show it to you here, like Tavily web search. And using this particular tool, we can search the web, get an answer out of that. You can read about all of this. So today we are going to start off with what are tools, how to use them, how to create them, and then later on we'll be learning how to use tools in Agentic Workflows and do a lot of stuff with them. Alright, so a general introduction. Tools can just be about anything, allow us to extend the capabilities of a model. Key to using model with tools is correctly prompting the model, parsing its response so that it chooses the right tools and all that. So let's start with creating tools. So when we are creating a tool, we need to keep it in mind that there are 4 things that we need to provide as an input for the tool to be created. First is the tool should have a name. Then it should have a description of what the tool is supposed to do. And this particular description is going to be used by the LLM to which this tool will get binded on later as an information of what this tool is supposed to do and what should the LLM expect from this tool. Then we have arg schema, which is basically the kind of schema that will be used to provide input parameters to this particular tool. Now we can use general schema like integer, string or anything, or else we can go for pedantic models as well. And then there is this attribute called as return direct. So as it's written here, it's only relevant for agents. So by default we need to set it as true when using tools, when testing out tools, like we'll do it here. And when we are using tools in Agentic Workflows where we do not want to see the output of the tool at that moment, we set it as false. By default, the value for return direct is set as false. So there are multiple ways of creating tools in Langchain. First, we are going to see how to create tools using the @tool decorator. Alright. So if you don't know what decorators are, you can learn about them. Decorator, in short, is a function whose job is to modify the working of the function that comes after it. So if I define @tool decorator here, whatever function I write here, I define here, will basically be modified as per this decorator. Here it will convert this particular function which I define as a tool. That's the use of this decorator. You'll learn more about it. It's used extensively in API programming and a lot of other things. So I'm defining a function here. I'll write it here in the comments. Defining a function to multiply 2 numbers. Okay. Here we want them to be integers. A very simple kind of a tool right now. By the way, we know that LLMs are not very good with mathematics, right? Because they are trained on language information, textual information. They're good with that, but they're not really good with multiplication and successive addition and stuff. That's where we can leverage tools. So it will take two inputs, b as an integer as well, and then we have to provide a docstring here. The reason is that usually when we are working with functions, we do not need to provide docstrings every time we create a function. But when creating tools, it needs to have a docstring, because this docstring is used as a context to the LLM that will call this function. So we have to provide a docstring. There's no way around it. We have to. It is a kind of a requirement for it to be a tool. You see, a description needs to be there, describes what the tool does. So here the description will be pretty simple. Multiplies two integers. Okay. Then we can straight up go for return a multiplied by b. By the way, to use the tool decorator, we need to call the class associated with it. Tools import tool. I think this is the one, right? Pretty cool. Yeah, you see, our tool is basically created here. Now we can look at the different attributes of this tool, of the tool generated. Let's see what attributes are attached to all of these for this particular tool which we have created. It's a pretty basic tool. So we want to print the name of this. You see, the first attribute is name. Then what we can do is we can print the args schema of this, and then we want to print the description of this tool. Description, right? That's it. So the name is multiply. As we can see, the name is multiply. It has taken the name of the function as the name of the tool. Then we have the arg schema, which is a dictionary, as you can see here, where the first value is type integer and the second value is b, which is also type integer as we have specified here. And the description is the docstring which we have provided. So it's absolutely important to provide a docstring to the function which we want to define as a tool. Now, if we want this particular args schema to be a Pydantic object, which we have to, we should do that for production level applications if we want everything to stay good and everything to stay uniform. What we can do is we can define a Pydantic object, Pydantic class. So we have to go to first from Pydantic, import base model and field, and then we can go here and we can just say define a class. What do we call this class? Let's call this tool input for now. Tool input inheriting from base model of Pydantic, and the first input is going to be a, which is an integer, and we define a field for it. Field is nothing, but you can consider it as a metadata for each of the input parameter that we define in this Pydantic class called tool input. Here the description is first integer. Let's call it that. The second, we can call it field description. Second integer, simple as that. Right? Now we have defined the Pydantic class. Now we want to use it in the tool definition. Now, one more thing I would like to add here. You see here, the tool by default took the name of the tool as the name of the function. If we want to assign a particular name to this tool, what we can do is we can simply write here multiplication tool. This will be assigned as the name of the tool. Then we can go for args schema, and we can specify the Pydantic class which we have created as the args schema, and return direct should be true because we want to run this particular tool and see its output right now. So what we basically did, let me minimize a little bit. Yeah, now you can see it entirely. What we did is, while using this particular decorator, we provided these inputs because we wanted to include this in the tool that is going to be defined. Then we can simply define, multiply the same, basically the same function that we have here. So I can straight up copy this, paste it here. All right. And I do not need to provide int here anymore because it will straight up take it from the Pydantic class. No issue with that. Alright, now let's see what happens here. I again want to print all of these things here. Now see, the name attribute has been modified to multiplication tool now because we explicitly provided it to the tool decorator. In the arg section, we have description as first integer, which is the field description, and we can see it here as well. And then the description is simply the docstring. And the arg schema is the one that we mentioned here in the Pydantic class. Alright. Now let's try and use this tool. So this tool by default, when it is not binded to any LLM, would work like a simple function. Okay, so the name of our tool is basically multiply, so we will go for multiply dot invoke. You see, we can use the method invoke because this has been registered as a Langchain tool, and because the arg schema is a dictionary, we need to provide the input as dictionary. Say that we go for A is 5 and B is 8. Right now it's working like a function because this is a function that has been defined as a tool right now. We're not using it with any LLM. We're just learning how to create tools right now. So yeah, we can use it in this way. There is another method which is more preferred. I would rather write it here. The preferred method for tool creation. Yeah. Why? Because using this particular method, structured tool.function class provides us more functionality, and it looks cleaner than using this decorator which we are using here at the decorator, right? So what we can do is, first of all, we need to take input. We can import the required libraries for tools, import structure tool, and then we define a function that we want to assign as a tool. Okay, I can just copy it from above. This particular function, we want to assign it in the form of a tool, and then what we do is, I want to show you another functionality of this particular structured tool class. In a lot of applications, we want to go for async functions. We are going to deploy it as an application to handle multiple requests without any particular function blocking the workflow. We can define another function here. So we call it a multiply, which is the async version of this particular function, because we're not using any Pydantic classes. Usually better assign a particular data type to each of the input parameters. We int again, but cool, it will do the same task, but this is just the async version of this function. Okay, right here, async version of the function that we want to assign as a tool. Now look at the magic of the structured tool class. What we can do is we can create a tool by just writing multiplier equals structured tool that from function I can comment it out as creating the tool that from function. Now here I can assign func equals multiply. Now in addition to that, I can also assign the async version of this function as coroutine. You can see it has a particular input parameter called as coroutine that says the async function from which to create a tool. So it also provides us a functionality where we can define the async version of the function as the same tool whenever we want to use it. I'll show you how to use it right now. So it's donezo, created, right? Now see, we can go for print multiplier. Oh, let's first see what goes on with multiplier, right? Print multiplier dot name. Let's see, it is multiply because this is the main function, and whenever we do not specify a name of this particular tool, it takes the name of the function, not the async function, because this is the main function. It treats it as a main function that is going to define the tool, and this is the async version of it. Okay, this is the async version. Now if we actually wanted to assign some kind of a name to this, simply go here, add another one, another input parameter. We can call it as multiplier. Okay, now let's see, a multiplier of integers. Sounds heroic, right? Go here, now you see it has changed. Okay, now let's run this, executing the tool. Okay, straight up go here, and you can say multiplier dot invoke, and you can go for a comma 2, my bad, and then b as, let's say, 5. Okay, see, we got 10. Now if we want to use this particular tool in an async environment, we just need to go here and we can go for a invoke. This will use the async version of this particular function. Go here, because this is, it treats it differently, so we need to go for print and add another statement here. Wait, now get 10. So basically with the same tool we can use the async version and the normal version, and it just looks cleaner while defining it, right? So I think this is the preferred method that we can use to create tools. Now there is another interesting method. A very good functionality that Langchain provides us is runnables. Runnables are basically, runnables can be of different types. You can learn about it in the LECL section of Langchain. But here what we're going to learn is how to define a particular LECL chain as a tool that we can use later. So I'll just import a few libraries here. Code output parser, that's basically string output parser, and I'm going to import Langchain core prompts, and I'm going to import the chat prompt template. We need to import this to make our lives easier, and say that I'm just creating an LECL chain right now. Chat prompt template from messages, or I can just say from template. I can specify hi. Please respond in this way, and I just input. Okay, here I assign input. Now what I can do is have already defined the LLM that I'm going to use in the chain. Okay. Go here. And this line, forget about this line, I just use it to check if the LLM is working. Now I want to define the chain. Chain is basically prompt and LLM and string output parser. Okay. Now let's just see if this chain is working actually. So we can go for chain.invoke and we can go for wrapper. Just let me go here and we can want to say alright in this way. What's up my G? Alright, so it responded in the way of a wrapper. So this chain is working. Okay, if this pipes and this entire notation is confusing you, just go and look it up on the LECL section. This is a very good functionality in Langchain that you can create chain of runnables. So each one of this is a runnable. Okay. Now what I want to do is I want to define this particular chain as a tool that I want to use later in my agentic workflow, whatever I'm going to do in my generative AI application. Okay. So I can simply go here and I can say as tool. I just need to go here and I need to assign it as tool and I can name it. I can add a name to it. Say the name is communication transformer. Okay, whatever, and I can add a description to this as defines the way the LLM responds. Okay, I've added a description to it, and now this has been defined as a tool. Now if I go here and I say as tool.invoke, it is raising an error because we know that whenever we are invoking a tool, we need to follow the argument schema, right? So let's check what is the schema of this args. So this is the schema. We need to provide information in this particular schema, right? So we can go as tool.invoke and input and wrapper. Alright, this also needs to be a string. As you can see, the type is defined as a string. Obviously, we can change all of this if you are using Agentic classes. I've told you about that, so no problemo. What's up, yo? Alright, so it's working. So now we'll be learning more about tools, how to bind them to LLMs, and we'll also look at some built-in tools that Langchain provides us.